I see what you mean. So this is the NYC open data. This is the one that one of the presentations they chose, but they don't always say what data set they're going to use. Well, that's fine, Yuri. That's fine. Here's
Yeah.
some background music.
Oh, yes. That's my wife is a pianist, so
Oh,
she's
nice.
practicing.
Okay, so let's see. Let's go back to our data set. Boris, how are you doing? You're on mute. Oh, your signal is not good.
Yeah, doing good. Sorry, my computer resources has been severely taxed with all the apps. Doing good, thank you.
Oh, okay, good. Okay, so folks, this is a data set we talked about last week. It's a data set of the month, which is the NYC 311 animal complaints over time. Let's actually bring it up. 311. Let's take the short version because it goes back all the way to 2010. If we take the short version, this is a data set we're going to work on. We have the created date of the complaint, when the people called in, the agency was referred to, the complaint type, animal abuse or dead animal or animal in the park, and then the description and the location. So a few community members have started working on this. Let's see here. We have right here, if we'll go to the chats, we'll see Manili and Juan have built a few, not Manili, Malini, it was Esther. So Esther shared this Loom video, and she actually built this app that has a choropleth with complaint counts per zip code, and then it's either dead animal. You can choose what the complaint is, and then Juan did Esther did something similar to Juan right here. Juan and Esther were building on the same choropleth. And then Juan built, if you would watch the Loom video, I'm not going to put it on right now, right here, you'll see that he built a pipeline. So this is the Postgres database. What it does, he shared his GitHub with us, it will pull data from the API. This is my the GitHub for the project. Pull data from the API on the New York City Open Data, and then put it into Postgres. Now he's limited to how much data he can pull at once, but he's going to pull the data, put it in the database, and then it reads from the database into the Dash app. Okay, he's going to put this on GitHub as well. He just has to clean a little bit of the keys and the passwords, but it's exciting because we have a pipeline now that can go from OpenAI into our own database, and then from that database, we pull it into the app to create the app that we want to create. Right now, we're creating a choropleth map with a drop-down, but we can expand and create any type of app that we want to answer the questions that we would like to answer. Hopefully this is understood. Hopefully I'm explaining myself okay. Do you guys have any questions?
No, I just noticed something. So using Carter map, I didn't realize that last time.
No, not actually. This comes like by default. Like you can open it. We are using OpenStreet. Let me actually take a look at the code here. You'll see. It's just a regular Plotly Express scatter map, but it's built on top of other open source maps. We used to use Plotly used to use Mapbox, but that not anymore. Here it is. So we're using the scatter map, and under the hood, the scatter map is actually what you've seen here: OpenStreet contributors, Carto, which you can hide. You can zoom in.
Yeah, the reason I was asking is like, OpenStreetMaps makes sense, but I thought Carter doesn't do open source. That's why I was
Oh,
curious.
yeah. So this part is open source.
Okay, cool.
So this is a scatter map of by descriptor, like what kind of animals are we looking at. We can see that there's a lot of purple. If you just focus on the purple, you see a lot of them are in the outer boroughs, outer Brooklyn, the Bronx, almost none inside Manhattan. And then we'll look at dog off leash, for example, reporting of dog off leash. The majority is inside Manhattan of those reports or close to Manhattan. Let's actually make this a little bit higher. I think we have a height function here. 600. So it looks a little bit bigger. Okay, better. All right, and now, and you can just double click on any one of them. This probably is a lot of descriptors, a lot of animals. We could limit it to like the top 10, because how many monkeys will we see here? Like 1, 2, 3, 4. Animal odor. How many are we going to see there with animal odor? 3. So we might want to filter out those that are really rare, just because the legend is a bit too long. And we just put the top 10 or the top 5, or we put a drop down up here, and then the user can choose whatever they want. They can choose all if they want, or they can choose one by one and see how they compare between what's the distribution of those animal reporting in the boroughs. So obviously deer, I guess there was one here closer to Long Island. Oh, this is dead animal, but it's reported as deer. So this is a mistake in the reporting on the API. But here we have descriptor deer. Sorry, deer. Most of them are seen in Long Island, and this goes back to 2020. Boris, you were going to say something? I saw you're off mute. Oh, Boris, internet is lacking. Okay.
Oh, I'm good. Thank you.
You're good? Okay. So this is one way to analyze, one visualization to provide to our users. Another visualization is this one via a bar chart. And then we have here, I forgot to fix the week. Let's see, we got an error here where the week is not part of it's not the correct word. So if we go back to the Excel sheet, where is it? This I gotta fix. Week group by the filter data, because I don't think we have week in here. I think we created day and year, but not week, daytime. Yeah, so we'll have to fix that. But anyway, that was a what is it called? A line chart to see the complaints over time. So we can build many, many more charts to continue developing this dashboard. The question is, which one would you like to focus on, right? Which one would you like to see? Esther is going to continue building some charts for the dashboard. Juan is going to continue helping with API and maybe adding more data, maybe cleaning the data. So we have to decide what kind of dashboard we want to create, like what kind of things we would like to look at. Any idea what questions you're curious about regarding this data set? What do you want to look into next? I think we have here as well.
If you don't have it, I don't want to push this idea, but like if we don't have anything better, maybe we can compare what I proposed before, like do like number of rats in each borough on given day.
Okay, let's look at that.
So like do like a rat competition.
Rock competition. Okay, let's do that.
It's not. Yeah, it's not. It's going to be. I don't think it's going to be like a very rich visualization. It's just a kind of. I mean, you can do distribution, but mostly it's going to be like a just five lines over time.
That's fine.
I mean,
Let's look. So the options we have in let's look if it's a descriptor or let's take a look. Yeah, it will be descriptor. Okay, so we got the descriptor type. It would be rat or mouse. And it's probably usually a rat that they're announcing. And we have the distribution, not over time, but over by borough. So what you're saying, one thing we could do is look at maybe like a line chart of the distribution over time. Is that what you're suggesting?
yeah, it was like five lines showing 5 boroughs.
Okay, let's try that. Let's try that. So what we have to do is go back to the code. Because this one is not working, let's delete this line and we'll use it here. So we'll say, let's do it by create a date. Let's do it by day or week. Let's see, 2025. Let's do it by week. Let's go back to January, but then we have a bigger data set. So let's do it by week. Okay, so let's look at what we see here. First, we're going to take the value of the dropdown complaint type. Let's look at the value of the dropdown. Animal use, dead animal, no. So we need the, let's just filter the data to descriptor. Okay, filter, not complaint type, but the descriptor dropdown. Descriptor, where's our dropdown? Okay, here's a dropdown. Instead of complaint dropdown, complaint dropdown, complaint description. Description. Let's put that here. So it's the ID of the, we're going to listen to the value of the complaint description, and the value is going to be for D in description in, I think we just call it description. I think it's just called description on the Excel sheet. Let's see. Descriptor. Okay. For D in descriptor, we don't actually have to add value and labels. We can just say, DF descriptor. This should work for the dropdown to get all the options. Is it called DF? DF, do we call it? Yes, DF. All right, so DF descriptor is all the options. And the first option we'll just do, let's do multi-false. Clearable false, and we'll do the first option as DF descriptor 0. And we'll change that to rat. That should work. Let's see if our dropdown works. Oh, come on. Before we move on. Make it a little bit bigger. Okay, let's see. Do you mean descriptor? Yes. It's a capital D. I didn't know. Oh yeah, it's capital D in the Excel sheet. All right. Okay, so let's see if our dropdown works first. Neglected, tortured, cat. Oh, but we need unique. Rat or mouse, we need unique versions. So we'll do descriptor, unique, and we'll sort them alphabetically. And then we'll just choose rat or mouse. Okay, so we have our dropdown. Now that we have our dropdown, let's add it, listen to it in the callback. So the value of the drop down, complaint description. We're going to listen to a selected complaint. Selected description. Let's leave it as complaint. And then we're going to filter the data on the descriptor column. DDF complaint type, no, descriptor. We're going to choose whatever the drop-down shows to filter the column. Equals selected complaint. So now we have only the rows where the user chose rat or mouse when they choose a drop-down rat or mouse. Okay, they'll go here, they'll choose rat or mouse, and then that's the only rows that are going to exist. Okay. Make sure it works. Smaller than, not supported between instances of float and string. What line is this? 42. What's the error there? 42. Why are we getting this error? Sorted, DF descriptor, unique. I don't. Any idea why we're getting this one? Unique. It's so weird. Because that's just unique values of the DF descriptor. Okay. Maybe it was something about sorted. Didn't work. Oh. Maybe you can just sort. Well, that was weird. Okay, anyway. But now we have it. We can always sort before. Right? Rat or mouse. Okay. Okay, so we can choose rat or mouse. And now we have to filter the data. So we only have rat or mouse. And now, like Yuri said, we're going to filter by group. So let's do that. Boris, please stop me if you have any questions or something is not clear. Okay.
We'll do it. Thank you. No worries.
Okay. So now we don't have week in the data set. DF week time period here. DF week will be equal to the created date. We'll extract the week and S-type string. I don't know why it needs to be S. Okay, the S-type string. And then we're going to filter the data based on that. All right, let's take a look. Week, complaint type. Sorry, descriptor. Count. Okay, let's see what we get. Value of y is not the name of a column in data frame. Okay. Okay, so why week? So let's print out the data set. Print weekly counts. Not weekly counts. Let's print weekly counts. Call head. Let's just see what it looks like. We should immediately get the printout because the callback has an initial value. Okay, so we get week, descriptor, and count. Count. And here in the error it says value line chart. The value of y is not the name of a column in a data frame, except expected one of unique. Wait, are we using the right data set? Filter DF. No, weekly counts. Got to put the right data set in there. The right data frame. Okay, let's see if this works. Now that we're using the right data frame, the weekly counts. Let's see if that impacted. Okay, so we get on week. We should fix a little bit the labeling there, but we get trend for rat or mouse. Number of complaints. This is the beginning of 2025. Well, we can then compare with COVID and then put the whole data set. Let's put the whole data set in there. Let's see what it looks like. If it works. Oh no, the whole data set that remains parsing with, we got to change the parsing. Okay, let's just do the short data set for now. Okay, so we see that from January 2025, the first week, this is the second week, this is 6 to 12, this is 13 to 19. So rat complaints, we had hovering around the 60 to 80, or maybe like 70, 73 to 100 in January. And then it slowly goes down in February, the beginning of February, and slowly goes up. But it hovers around the 80 complaints per week. 80 complaints per week. So we want to do, let's get rid of the COVID annotation. We don't need that in there right now. That was for something else. Number of complaints, trend 4. Before neglected, trend 4 rat mouse complaint. Over time. Okay, so we have a figure, but now, how do we see by borough? So what we could do, like Yuri said, we could add the color for the borough. Let's see if that works. What is is it with a capital B? Borough. Or is it called city? No, city is neighborhood. Borough. Computer's freezing on me. All right. Borough as the color. I think we have only, I don't think it's including Yonkers and other errors. Okay, let's see. Oh, because we regrouped it and we didn't put borough in there. So let's put borough in the grouping. Borough. All right. We have the borough type. There we go. Yuri got it. We got it. Oh, you're. I think you're out of the. Okay, added you, Yuri, because I saw you were off by mistake.
I don't know. Yeah, sorry, I was pressing wrong button, so I'm back. So I'm in and out. That's actually that's pretty cool. So you can actually see it's competitive.
Yeah, they're like they're. It looks like they're well distributed. Staten Island. Now, again, you shouldn't confuse this with number of rats. It could be just number of rats that are. This could show us the tendency of people to complain about rats. Maybe in Staten Island, people care less about seeing rats. Maybe in Brooklyn, is that Brooklyn? Yeah, people care more about seeing rats on the street. Maybe it's something else. Maybe it's the all the rats are like the first assumption, the same number, but in Staten Island, the number of rats that actually are seen or actually above ground is a lot smaller. Maybe a lot more, a higher percentage lives below ground. So it's hard to.
Well, it's suburban, right? It makes sense, right? So they're not gonna go on the street. They have like other places to be. Yeah. In other boroughs, it's only streets, so they have like no choice.
Yeah, that could be the case, or it could be a correlation of like amount of food or trash available for them. if there is obviously more trash and food available in Brooklyn, more rats are going to, and mice are going to thrive in Brooklyn than in other boroughs. Let's see if we see interesting trends. So for all, no, some of them went up, some of them went down. Every week is like different. For some boroughs, it goes up. Brooklyn went up here in this 5th week. And for most of the other ones, Manhattan, Queens, it went down this week. But that's kind of like random, nothing very specific, no long-term like 2-3 week trend. Staten Island stands out to me because it's 1, 2, 3, 4, about 5 weeks where it's pretty much the same number of complaints. Didn't really go up, didn't really go down. Probably the whole 3 months, it's very similar, 6 to 10 complaints. Well, I guess 6 to 10 is like a 40% difference. And then we have here they're all the same. Right, only here there was a big amount of increase in Brooklyn. It just jumped from, in 2 weeks, it jumped from 7. It almost duplicated itself, multiplied.
Actually, this would be like interesting analysis to do. If you look at spatial distribution in Brooklyn between those 2 points, it will tell you, is there like a new area where like it manifested itself, where it wasn't, there were no complaints before, or
like like a scatter
maybe,
map.
Yeah.
Okay, let's
like specifically for those 2 points, like a compare.
We can do an animation scatter map. Let's see. So we already have our scatter map. We'll just copy it. We'll create another graph in the layout, and we'll say this graph will be DCC graph, and this will be scatter map 2. Let's do the second one. Let's add it right here. Oops, not here. Another output. Scatter map 2 figure. So we're going to have to build a similar figure to this scatter map. But we'll try to make it animated this time. And we'll call it figure scatter. And we'll say, is it, figure, no, let's call it figure scatter 2. 2. Height 16, descriptor. Probably don't need descriptor since they're all going to be the same. Only one color, like only rat. Hover name, we'll figure out later what we need in the hover. And in the scatter map, let's put this all in one line. Dark. And maybe we can do an animation so we can then divide over time. We can filter the time, but let's do an animation. I don't think it's, I can't remember if it's called, let's try frame. You can check it later. See what error we get. All these errors. Okay, let's look at our map. Do we get an error? No? Okay, that's a good sign. No error. Wonderful. All right. Here's our well, this is not rats yet. This is neglected. So let's do rat on mouse. This is from January 2025. Dead animal, either animal in the park. We could just do color for like complaint type, but that we can look at that later. And we know it went up here from, where was it? Here. From 4, rat mouse, from 4 to 12 in that particular week, from the 17th, 2 weeks. No. Yeah, 2 weeks to March. So the 17th, I think, is here. Wait, I don't think it's ordered, right? 3/10, March, February 10. No, this is not in order. So let's fix this order. shoot, this is going to be a little bit more difficult. We could use Claw for this because the week, the format is in string, if I'm not mistaken. Yeah, it's a string type. Yeah, so we'll have to fix the format here to show us, instead of all this, we'll see like week 1, week 2. So let's do this. A quick way to work with Claude or ChatGPT is to save instead of feeding the whole Dash app and the whole data set with the callbacks and everything to ChatGPT and asking it to help us, we just need this part, right? Then we want to know how to sort the data set by week and change the week to 1, 2, 3, at least 2025, 1, 2, 3. So let's do that. The best way to do this, from my experience, is weekly counts, save, or to CSV, and we'll call it weekly counts. And now that we have it saved, let's do index false, so we don't get another ID there. Okay, weekly counts. And now we'll see that this will be saved as soon as the app runs. Go back, go forth. Weekly counts. Where's weekly? Oh, I have to open this first. Okay. Let's go back to this thing. Weekly counts. So this is our data set. Now let's go to Claude and we'll say we want this column to look different. Oh, this column looks horrible. 12:30 to 5. It is sorted, so that's good. But we wanted to say, well, let's decide together what we wanted to say. Claude. Okay. Let's bring in this data set. Hope it's not too big. We have this data set, or this data set has is it capital W? W. Week, yeah. Oh, shoot. Has the week column. Has a week column. Please use pandas. Now help me out here, guys. Please use pandas to let's give it an example first. Here's an example of the first row. We want to plot the weeks chronologically on a Plotly line chart. So we need the weeks to be in date format that Plotly can understand. We would also like the week values to be presented as, and then we'll say, I don't know, 2025, because we have a data set with many years, so we'll say, how do we want to present do we want to say like 1, 2, 3? Does that seem like it makes good sense? 1, 2.
Well, if
3.
the time span is longer, how about
How about what, Boris?
Do you want to add it? Do we need to add like year hyphen, the number of quarter or a quarter number?
Well, week. We'll do week because
Just
we're
in
doing
case,
week.
Oh, wait, I'm sorry. Yeah. I was just thinking if, it spans over 2 years.
I was thinking about that, but I don't know how, because then it's a string, I think. But let's give it a shot. Let's do what you said.
Okay.
So say week
Or
balance.
on that note, do we want to do 25 hyphen W1 or I don't know.
Yeah, that looks better. You're right. For the first week, 2502 for the second week. And so on. Let's see if it works. I wonder if it's possible to plot that if it's in a string. Maybe it'll just plot it by it will just sort the data set. Even if it's a string, it'll sort it correctly. Okay, let's see what it does here. We're splitting. Okay, first we're going to split the week value on the /. So it splits it. And then it turns it into a pandas datetime and assigns it to a new column called week start. So we're splitting it and then pandas datetime. And then and then the first week will be the minimum. The first assuming the data set is not sorted, it has to find the first week, which row is the first week as minimum. And then it'll say it's going to create a new column called week number. And here it's going to take the week start minus the first week. Ooh, this is pretty complicated. Calculate weeks from the first week, adding 1. So we start at week 1. So it just calculates how many numbers we have. And then it's creating a week label. Okay, so this could work, what you said, Boris. And then it's creating a pivot table. I wonder why it needs a pivot table. But anyway, let's see. I don't think it needs a pivot table. Let's see what we have here when we just do this. Okay, I'm going to copy this. I'm going to create a new file, and we'll call it week test. Fine. Like this. Let's see what we get. Print, and this is usually how I work with to try to solve issues. Okay. So by doing this, the first couple of, we will have rat mouse with the drop down. Wait, it still has a slash. That doesn't make sense. Oh, no. We're looking at week. It created other columns. We have week start, the week number. Week number is 1. In January is number 2. In the second week, third week in January is number 3. Oh, we chose week 1 as December 30th. Okay, let's see what happens. And then the last one we see sorted is week 11, and we created the labels here. All right. So I don't know. I think we can create now, if we use this, and we can just put here in the y-axis, we'll put, in the x-axis, we'll put the week number or label. The color would still be borough, and we don't need to count. We don't even need to create. I don't think we need to. Yeah, I guess we can group by a week and then create the count. Okay, let's give it a shot. Let's see if this works. Let's extract all of this. I just don't know how to do the label part. That's where I'm a little bit, maybe we'll go back to it. All right. Take a look, folks. So we have our data set, filter data. Well, he called it data, so let's call it data. We're splitting the week, creating a daytime, get the minimum, get the numbers, and then create a label. And now we'll create the figure. We'll call it data, week. I think we should see, have count in there, print data. Let's see. Okay, let's see what gets printed out. Descriptor count. Yes, we do have count in there. Good. So we'll put the week. We won't put week. We'll put week number. And then account and then borrow. Let's see if this works. Oh no, we're not doing it here. We're not doing it in the line chart. We need it here. This stays the same. Scatter map frame, week number. Callback line chart. Animation frame is not the name of a column. Expect a unique key. Week number, isn't it? Week number, that is the name of a column.
So it's December 30th labeled as week number 1. So it's not like numbering, right?
Yeah, you're right. But that's not the error that we get. You are right, but we don't have an error there. The error that we get, Boris, is value of animation is not the name of a column in data frame. Are we using the right data frame? Yeah, we need to use data. I always forget that. Okay, now let's see.
Cool.
Okay. A value of hover name is not the name of a column in data frame. We don't need this hover name because we didn't add it. That's fine. Fixing bugs, fixing bugs. This is a value of lat is not the name of a call. Oh, we left the lat out. That is not smart. Latitude, longitude. Okay. But then we can't group latitude and longitude by week. That wouldn't make sense because it would be different. That's the problem we have here. For a line chart, it's fine to do a week and a count because we're not using latitude and longitude. Just how many per week, right sightings or dog sightings. For a scatter map, I think that would be a bit problematic. We don't need to group by in a scatter map. It's just going to show us every week all the latitude and longitude. So we don't need to use a group by data frame for the scatter map. We just need all the data there with latitude, longitude, animation frame, week number, but we'll have to do it on the filtered data set. Filtered DF. Where is it? Week start. Filter DF. Week start will be ready. We will apply this on the week. Yeah, it's not the data part that needs this. It's the other data set. Okay, we passed the hour, so 45 minutes. I have to jump off here, but let me just see if it works. If not, Boris, I'm going to give this to you, and you can try this out. Caveat, okay, we're doing on the same data set. That's fine. Okay. We just got, this is sorted the other way around. It's going from March to January, but I think we got it. If we look at, these were the highest months in 9 and 8, where we saw like a jump, and we can see where this is neglected. Let's look at rants. We can play. Oh, it's quick. All right. 9 is, we can see here. If this is 6, it's like February, end of February, and then here's where I think we saw a jump. See here that it's not concentrated like we thought. It's still in Brooklyn and Manhattan. Here, the 9 where it jumps, there's a lot in Brooklyn around this area. But again, not a big concentration. This area is pretty wide. If it was all in one park or one neighborhood, but it's not. But that was a good analysis.
So we specifically want to see the difference between 2 weeks in Brooklyn, right? That's a blue line above. Like
yeah, this one and this one, which is weeks 6 and 7 and 8, I think.
Oh, can we look at the map?
Yeah, 8. You see here, different neighborhoods, and then 9. It's 8 and 9 actually. Is here. Here is the biggest jump. Yeah, 12 complaints. See, so it's a big jump, but it's not like everything happening in one neighborhood. So I think it's a good analysis. Well, and this is only again for 3 months, Yuri. When we have the whole data set for 10 years, we might see bigger jumps in certain weeks. But I like this. We created a nice visualization.
So you can actually like, I think you can do correlation with weather, first of all.
Yeah.
Right, because well, you can do it's interesting. You can do like just averages for like basically average per over years over the same week, and that will give you interest because weather changes. But specifically, if you want to see correlations, I think it has to look at the specific weather just to see if it was weather based or it was based on something. And then actually that would be like really interesting to do. Do correlate, like find out what jumps got caused by the weather and what jumps would be caused by something else.
Yeah, I think that's a good idea, Yuri. I have to jump off for a personal appointment, but I'll post the code on Charming Data then when I'm back at the end of the day. And if you or Boris want to try and tackle that with weather, perfect. If not, we'll try and tackle that next week to do the correlation.
Okay, cool. Thank you so much.
Thank you both.
Cool.
Cool.
Thank you.
Thank you.
Thank you.